Hey guys, welcome back. This is Harsh, and the topic for this video is uh, write an algorithm for searching the element in a binary tree. So we are basically trying to find if element is present or not present in a binary tree. Okay. So just for the guys which are joining us in this video, so a binary tree data structure looks something like this, and each node has a maximum of two child nodes, and we want to find the we want to find if an particular element exists or does not exist in the binary tree. So first of all, I guess we should start by going through this. So yeah, uh, so I have created some utility function to print whatever problem I'm solving on daily basis. So yeah, and all these problems are which I'm picking and making videos are from the Data Structures and Algorithm ADZ book by Narasimha Karamunchi. You guys can find it on Amazon if you want to go through that book yourself. Yeah, so let's create our binary tree. So I had a class for binary search tree, but I guess it will serve the purpose for this as well. And again, I had created a utility to fill that binary tree. And by filling I mean I don't want to add elements to the binary tree again and again, because I'm creating all these functions and algos and I don't want to add those again and again. So if you guys want to see, I'm basically just adding few elements and nothing else. So yeah, this is all. I'm creating a new object and I'm adding few elements in that and returning that tree. This is making my work easy here, so I can just focus on the algorithm and not add elements every time I'm solving a problem. So how do we search an element in a binary tree? There could be a couple of ways we can do this. Let's first search the recursive way. How can we do this recursively? And how can we do that? Is at each node we will need to check if the element which we are looking for uh, is matches that node, and if yes, then we return that node, or we just return true the element found, and else we search for that element in the left subtree as well as we search for that element in the right subtree. And for that we can again call our same function because we are solving it recursively. Let's do this, guys. I'm just going to copy some text which I don't want to type again. Correct. And I'm going to pass the root node of my tree. So let's create this function. And I want it to be returning either true or false, so I am making the return time as bool. So first thing, guys, now you must all be remembering we need to check if the root is null or not, and if so we'll just return false, which indicates element not found. Else, or we can just write if the root data matches with, okay, we also need to pass in the data which we are looking for. Okay, right? So as if the root matches the data which we are looking for, we return true. And even if that is not the case, we'll do, we'll look for and for the element in the left subtree, correct? So we'll use where element found in left. And what I need to do, I just need to call the same function again. See guys, this is recursive functions are easy once you get the basic understanding, because you don't have to write a lot of code, you just need to understand what we are trying to achieve. So what I am trying to achieve is the same thing here. uh, Look for that element in the left subtree, correct? And also I need to check in the right subtree, it might be present there, I am not sure, it's a binary tree, right? So it could be present in left or right subtree. What I need to do here is I just need to check if element found not equals to false, which means the element was found in the left subtree. Return true, correct guys? Else we'll repeat the process here and check for the same thing. So this is a basic algorithm. So what we are doing is we are looking. Why is it throwing me not all code algorithms value? Okay, okay. I need to pass a default value. Default value it says. So let's just use. Instead of returning at each point in our program, I am just setting the element found as true or false, and then I will just return the element found. Same here. So what I'm doing is I'm removing all the unnecessary variables which we had created in the starting, because I know this function will just return me what I'm looking for. So hence I need not pass uh, anything else, and look for that element in right. I hope guys this is pretty clear now. So we'll just repeat what we are doing here. We are starting with the root node and we are looking for the data in our tree, and if the root is null we just return false, and else we set element found as false, and if the root data matches we set it as true. And else if it not matches the root data, we are looking for that element in the left subtree, and if this returns true, like if this is not equals to false, then we set the element as true. Else we look for the same element in the right subtree, and if that returns false, then we know like the element does not really exist. But if either the root or the left subtree or the right subtree returns true, then we are setting element found as true and we are returning that thing. So let's just run our program. We can search for 9. It should return 2. Okay, I have not called my function. I need to call it in the main method. So these are few other problems I have solved. You guys can check my GitHub repo, and all these you can find there. So these are present there. Let's run our program once again. See, whatever element we are looking for was found true. We are looking for 9, correct? Now let's look for another element which is not present. That would be, I guess, 99. It's not present. It should return false. See, false. So this is how basically we can find or look for an element in a binary tree using recursive function. Now, I guess we still have some time. Let's go ahead and uh, also do this same thing iteratively. Now, how do we find that? Using an iterative method. So I'll create another function. Cool. So now we need to write the definition for this function as well. So now we are not going to use the recursive function which we have just made. Let me just minimize all these. So this was the recursive function which we had made. Now we are trying to achieve the same thing using iterative function, the one which does not calls itself. Again, we need to start with if the root is null, will return false. Else, what we need to do? We need to traverse through each and every element in the tree, and I guess if you guys have been watching my last video, we were doing the same thing while we are finding the max element in the binary tree, and we were using the level order traversal for that. So I guess we can use the same for this as well. That will serve our purpose. So let's just use the level order traversal, and for that we need queue which will hold nodes of my tree. I'm queuing the first root, and now I'm checking while my queue dot count is greater than 0. It means if it is not empty, then do this. Now do what? We need to search for the element. So let's just create element found equals to false, and I just need to update it. Sorry for the spelling mistake. I just need to update it in case I found the element. So I'll start with this. I'm dequeuing the elements in the queue one by one, and I'm checking if my element which I just popped, its data matches the date element which I'm looking for. Then we can just return true here. I don't even need this variable here. We can just return the true. So this will break our loop, and the function will be over. So as soon as we find the node whose data matches the data which we are looking for. Else what we need to do is, as we just need to enqueue its left and right side. Okay guys, and right side, only when they are not null. Oh, somehow I press something else. Yeah, only when they are not equals to null I need to do this. What if we don't find our element till the end? We just return false. Yeah, even if after this traversing through all the elements, we never encounter a situation with the nodes data matches data and we are never returning true. So just return false at the end. It indicates the element was never found. Let's run this. See, it's returning false. And we can also look for some other variable. Okay, what are the variables which were present? I guess let's look for 10. Now this should return true. When this was, sorry, this was the cursive, this is iterative method. So yeah, it returned true. That means our function is working as expected. Thanks guys for watching. Do let me know in the comment section where I am lacking and what I can improve in these videos so that my future videos are better. Okay, thank you so much. Do remember to subscribe. Okay, bye bye.